You should have just watched volume 1.3 on how to build an advanced PLC trainer with analog. The first couple sections, volumes 1.0 and 1.1, were basically PowerPoint and other graphics to discuss why we were going to do what we actually did. And then the last one you watched was some construction. The one before that was a lineup for the parts. So if you've just stumbled in here, you need to go back to V1.0 and start there and then work your way forward. Welcome back either way. Okay, you can see we have the red and black wires from the first 6 LEDs. We've done our wire management to the tie-down pads, and you can see that the shrink tubing falls in various places because this red wire is going to be the shortest when it gets here, shorter than this one. You could have cut them to varying lengths so all the shrink wrap fell in one place. That's probably not a good idea because then it becomes too bulky. So now what we're going to do, I think, is we're going to run our conductors, all of them, out this end of the box. So we want the cables to come out this end. So these last 4 LEDs, we could come around here, or we can come all the way around and leave more of this space in here wide open for hooking up the potentiometers. I think we're going to do that. Okay, now you can see that we have the wire management finished for the LEDs. The red LED wires were individually spliced with multiple colored wires, the same colors that we used for the input devices. The blacks were spliced together into one common black, and now we're ready to install the potentiometers. Wire management is the name of the game here. And when you're tie wrapping these up, don't be afraid to waste a few tie wraps, and be very careful that you don't overflex the LEDs. Okay, we're getting close to being finished here. We basically have 2 masses of conductors leaving this box. Our digital inputs right here, 10 of them, and so you have 11 wires here, 10 switches plus a common. And then our LEDs, we have 10 LEDs, and then we have our black common, then we have our analog input, analog output. Now notice that I use black and red on the 2 potentiometers. Red goes over here to the end of our resistor, our dropping resistor. I tie wrap these 2 down. I took the red wire, twisted it, soldered it, and then put shrink tubing on it. So each of these dropping resistances drop the voltage down to 10 volts on each of these potentiometers. Then on this end, the 2 resistor assemblies are soldered together to a red wire that goes out through this bunch. Notice that for my voltage that varies when you turn the pot, I have a green wire here and a white wire here. Also with my analog outputs, I use blue for a common to keep it more identifiable than the black, and then I use green to match this side and white to match this side, and have all my wires managed through these peel off tie wrap anchors. Now these are too large, but this was all I could find, and I didn't want to have to order any and wait to finish this little project. So in some cases the wires aren't really clamped down that tight, but it's still going to provide some good strain relief. So when you're outside the box, you pull on these conductors, this takes up some of the strain. That's the whole idea. As a matter of fact, I may redo this a little bit and put something of a spacer, cut that tie wrap off, put in a piece of that gray sheathing that we stripped off, and then tie wrap down around that. Now this one's pretty full, this one's pretty full, and that one's not too bad. But this one right here definitely is not tight. I normally use black tie wraps because I don't want to see the tie wraps. However, I use more white this time to give you more of an idea. Unfortunately, I did use some black here by habit, so there's 1, 2, 3, 4, 5 black tie wraps. So you don't go overboard with tie wraps, and don't be afraid to cut one off and throw it away and start again. Tie wraps are dirt cheap. Wire is cheap, solder's cheap. What isn't inexpensive is your time. So always conserve your time. So I think we have everything connected into these two bundles. Now remember, this one's our output LEDs and our analog signals. So the next step will be to manage these two groups through the side of the main box, and then identify the other ends to hook to the terminal strips on the programmable logic controller I/O module wiring blocks. Almost complete. Well, here's our digital I/O. Goes down through a grommet, comes out of the box. Here's our LEDs, comes down through a grommet of the same size and out. Then we have our analog and the 24 volts DC from our power connector. That also travels along with the analog. So this bunch is 2 potentiometers, 2 meters. This is 10 LEDs, and this is 10 toggle switches wired in parallel with push buttons. So, first thing I'd like to say is the box is too small for your project if you've not done stuff like this before. This is way too congested. It's nice and compact, but the chances of damaging your work is very great when you have it's very congested like this. You have to be very careful to anchor down your conductors, so as you're wrestling around with this, you're not pulling on the pins, you're not pulling on the solder joints, and you're not stressing this structure. I'm going to test everything now to make sure that the continuity is still good and everything still works properly. At this point, if I had to replace an LED or a switch, I would probably cry first and then get to it. But I would be disappointed if I had to go in and replace any parts. If I had to do this over again, I would use a bigger box. I would probably space these further apart because I do have this excess space down here. So I would move the push buttons down within a half, 3/4 of an inch from the edge, and then I would evenly space the toggles in between the push buttons and the LEDs. I might even move the LEDs down a little bit just to make a little bit more space in here. Another thing that would make this easier, obviously, is to use a larger box and to use terminal strips. Terminal strips could have been mounted into the bottom of this box, and all of these connections went to terminal strips, and then from terminal strips to actual cables, because remember, all these wires came out of cables that I stripped the gray nylon sheath off of, pulled them out, and then used them individually. So next step is to check everything out, meter it out, and then attach the other end of the wire bunches to I/O arms for I/O modules. So now I'm testing the switches again, and to this meter I have the common red wire from the toggle push button combinations attached to the black lead of the meter. And then I'm taking the red lead of the meter, and one at a time, and because I know my color code, I go to brown, and if you watch the meter right there, see, push button, and then I go to orange, toggle switch, push button, yellow, toggle switch, push button, and then I go to blue, toggle switch. Now, if you leave the toggle switch on, nothing happens with a push button. Remember, they're wired in parallel. So if this is closed, closing this doesn't change anything. Push button, blue, and then I think we've got green, and white. Then we go to the next group, same order. Brown, let's see, 1, 2, 3, 4, 5, 6, I think it's this one, yep. Orange, yellow, and blue. Okay, that tests this. That's our digital conductors, and they're all good. Now to test the potentiometers and the meter, that's going to take a little bit different setup. So I'll be right back. Okay, now we're hooked up to test the potentiometers. Okay, if you watch the needle right here, when I touch one of these, see, counterclockwise decreasing, clockwise increasing. The other one is a white wire. It's either this one or this one. There we go. You can see that potentiometer works. So we've tested both meters, we've tested both potentiometers. Next is the LEDs. Okay, we'll reduce the lighting a little bit. And I've got a 24 volt DC power supply hooked up here. And I've got my wires divided up. So we'll try it without any extra lighting. So there's the first white LED, second white one. Then we go to yellow wire. It's our first blue. Then we go to blue, our second blue LED. Our green wire, and we get a green LED. Our white wire, and we get another green LED. So that was the first 6. And then the last 4, we go with our color combination again. Browns first. There's an amber, orange, another amber, yellow, a red, and blue, another red LED. So that tests all of our LEDs. So we've tested everything on the device now, and everything works externally to the cables. So the next step is going to be to attach it to the I/O arms, and then hopefully, if we have time, hook up the PLC and, I don't know, do something. So the project's pretty much done as far as the box goes, but we'll continue on. Okay, we've got everything hooked up now, so we're going to demonstrate it. I don't have the vernier knobs on here. We don't need those to demo it. But you see I've got cabling run, and what I did was I think I told you before, I reinserted some of the wires into the sheathing that I stripped off. You won't be able to get as many back in as you took out because they don't come out that easy. So for this particular one, I think there's 8 conductors in the cable originally, and I was able to slide 6 back in. But anyway, that tidies it up a little bit. You see I still have some wiring to tidy up here to make it look a little neater, and put the vernier dials on. So first thing we're going to do is look at the digital inputs. So I'll drop the lights down, and hopefully you can see the LEDs on this input module right here. See, I don't know if you can see the light blinking right there at the end of my finger. I think we'll do a close-up of that. Now we're a little closer up, so you can see the LEDs coming on. I'm using the first switch to test the, there you can see, while you're at it, if you look at the output over there, see I'm running a timer to sequence the output, so you can see the output LEDs coming on. Now those are the LEDs on the Compact Logic's 1769 modules. I have a little program in the controller, so when this switch is on, it sequences the LEDs, or you can just use the toggle switch, and it's just running the 10 LEDs in sequence. Also note that I'm using the analog inputs going into the controller, and then in the controller logic controlling the analog outputs. So I don't know if you can see the needle moving. Remember, these are 10-turn potentiometers. By the way, I did have 2 mistakes. I had 2 wires in the wrong place on each of these. It was one mistake. It was the way I read the pin numbers. Also, I did not wire up the common. I missed a common. So I had 2 mistakes I made wiring this up. Other than that, it all works. Well, that pretty much wraps it up for building an advanced trainer. There was one thing I didn't see in the video that I know I did, and I thought I took a video clip of it, but either I accidentally deleted it or didn't have the camera on, and that is testing the meters. Now, the meter, the hand meter, you know, the volt ohm meter, the meter that you troubleshoot with, the digital meter, it has batteries in it for the resistance measurement. In other words, when you measure ohms or resistance with a meter, you are running current flow through whatever you're measuring, and then that current flow is being interpreted on a logarithmic scale on the meter, and of course the less current, the more resistance. So you probably noticed when we were doing resistance checks, it looked like the needle was going backwards. It really wasn't. More resistance is less current. So the closer to the zero end of the meter is high resistance. So more resistance, less current, inversely proportional. Anyway, checking the meters themselves for which was which and that they worked. If you hook the ohm meter up to, you put your hand troubleshooting meter, your volt ohm meter, into the resistance mode and put the leads on your 0 to 10 volt meter, it will register something because you're pushing current flow through it. And those d'Arson of all meter movements are like little motors that wind up against a spring. You know, there's a permanent magnet in there, and then there's a coil on an armature, and when you run current through it, it opposes the magnetic field and then pushes the needle up against the spring. And of course the spring is what really gives you the limit of the needle movement based on how much current you ran through it. So if you hook what I did was I hooked my volt ohm meter directly up to each of the wires. Remember, there was a green and a white to determine which was which. So you'll get an indication on those 0 to 10 volt meters on your box if you hook the ohm meter up to the wires going to them. That was the only thing I didn't see in the videos that I actually did. As I said, the box could be easily be larger. And actually, I figured out a way to make it into an even smaller box, but we're not going to go there. But you should use a larger box if you can. If you want to wire up all 16 inputs and outputs, I mean, switches and LEDs are dirt cheap, wires dirt cheap. It's a matter of space on your box. And you could see how congested the wiring was once we got most of the components in there. So I'm not planning on a next section for building an advanced trainer. However, I'm kind of leaving it open. If I can think of some way to add something, I'm more likely to build a completely different device that has sensors on it, like proximity switches, photo eyes, etc., that I can hook up to PLC I/O modules and do something with it. So thank you very much for watching this. So I think in total we produced a video on principles of electricity magnetism, specifically electrical characteristics of backplanes. And then we followed that up with the first section on building an advanced trainer, which was more on the backplane and how the I/O modules interface. Then we did another section where we actually showed how we connected all the inputs and outputs to the cards. This is all graphics now. And then we did a couple of these video clip sections where we actually build the trainer. So thank you very much. Today is July, 13th, 14th, 2013, and the RS Logix 5000 manual should be available within a month or two. We're building a new website, and the software I was using that I made my own website with, they use a particular type of FTP file transfer protocol, and my server with Yahoo no longer uses that. One of them uses Apache and the other doesn't. I don't remember which is which. Nonetheless, right now I'm kind of stuck in limbo between the old WYSIWYG software and a friend and relative who's producing a new website for me with blogs and much more interaction with all of you wonderful people out there who bear with all of my little mistakes. And for those of you that every once in a while I do get a complaint, I've only gotten like 2 or 3 out of something like, 300,000 views. I don't remember what the number is. But when you go looking for something free on YouTube, most of the time you get more than what you paid for, but you never get less than what you paid for. So anyway, it's a real pleasure doing these, and God bless, and we'll see y'all later.